Hello all, hope you are fine and doing well. Myself Dr. Ankan Bhattacharya, Assistant Professor, Department of ECE, MIT Bishnupur. Today, the topic of my discussion is Dipole Antennas Revisited. Let's start. What is the dipole antenna? A dipole antenna, or more specifically a folded dipole, is an antenna with two conductors connected on both sides and folded to form a cylindrical closed shape to which feed is given at the center. The length of the dipole is half of the wavelength, hence it is called as a half-wave folded dipole antenna. The frequency range of a folded dipole antenna is 3 kHz to 300 GHz. Construction and working of a half-wave folded dipole. This antenna is commonly used with the array-type antennas to increase the feed resistance. The most commonly used one is with Yagi-Uda antenna. The following figure shows a half-wave folded dipole antenna. If the length of the dipole, that is the total wear, equals the full wavelength lambda, then it is called as the full wave dipole. Construction working of a full wave dipole. Both the positive and negative peaks of the wave induce positive and negative voltages respectively. However, as the induced voltages cancel out each other, there is no question of radiation. Next, let's observe the full wave dipole antenna pictorial representation. It can be observed that the two half-wave dipoles are simply joined to make a full wave dipole, and the length of the antenna element here we can observe is lambda. Let's observe the animated representation of a radiating dipole. Here we can see that the electric field is in the horizontal plane, whereas the magnetic field is in the vertical plane. Let's observe the following three figures closely. In the figure 1 and 2 we can observe that there are 2 point charges. One is a positive point charge and another one is a negative point charge. Now these positive and negative point charges are interchanging their positions, thereby giving rise to a changing electric field. Now this changing electric field in turn is generating a changing magnetic field. These changing electric and magnetic fields now together comprise the electromagnetic wave, whose wavelength is equal to twice the length of the antenna element. These figures represent the dipole antenna element whose length is equal to capital L, and we can see that both the ends of a dipole element are getting alternatively polarized. Now coming to the short dipoles. A short dipole is a simple wear antenna. One end of it is open circuited and the other end is fed with AC source. This dipole got its name because of its length. The frequency range of operation of a short dipole antenna is around 3 kHz to 30 MHz. Coming to the construction and working of a short dipole. The short dipole is a dipole antenna having the length of its wear shorter than the wavelength. A voltage source is connected at one end while a dipole shape is made, that is, the lines are terminated at the other end. The actual size of the antenna here does not matter. The wear that leads to the antenna must be less than 1/10 of the wavelength, that is, L should be less than lambda by 10. Now let's observe the pictorial representation of a Yagi-Uda antenna, where dipoles and reflectors are involved. The incident waves fall on the antenna and they are reflected back by the reflectors. These Yagi-Uda antenna used to be installed on the rooftop of almost each and every house. These are the few references which I have consulted for preparing my presentation. That's all for now. Thanks for viewing my video. If you like it, do give a thumb and don't forget to share. Thank you.